Hi, everyone. It is such a delight to be here. I think a lot about augmented documentation and helping people read complex information, and Stanford is just a really fun pilgrimage in that regard. This is one of the places where Don Knuth worked and developed Tech, the program that we use to create our research papers. There's also a number of really exciting projects around creating interactive textbooks and interactive reading materials for children that I think are also really inspiring for the type of work that I take on too. So it's just really exciting to be here in this environment, sharing this set of work in this place where a lot of really cool historical work has taken place on this topic. So the focus of today's talk is designing the interactive paper. And I think a lot about building interactive information interfaces that help people interact with and understand complex information. And I think one of the environments in which we interact with complex information that I think is often hiding in plain sight is our PDF reader for scientific papers. And I think if you're looking for a complex information presentation, you really can't get much more complex than the scientific paper. And one of the reasons, there's many reasons for this. To name just one of the reasons for this, it's the vocabulary within scientific papers. So for instance, within an individual paper, you're going to perhaps encounter many different acronyms, perhaps symbols and other types of formalisms that people use to encode certain types of ideas. You'll also see a lot of invented terms. So we researchers like to assign new shiny names to the things that we do and explore new concepts. So inevitably, you're going to have some of this invention of new terms that haven't been seen in other documents before. And one of the challenges with reading papers is that simply there's this overabundance of these instances of vocabulary. And then when you consider understanding at all of these different levels, when it comes to understanding an individual term, to understanding a sentence and the propositions that it entails, and to understanding the larger concepts that come apart from a paper as a whole, this ultimately results in a large amount of extraneous load as someone is trying to piece together the ideas within that paper. And as someone who myself thinks a lot about interaction design, well, it's natural for me to ask this question of, how could interaction help us read papers like this one? And there's a lot of history, a lot of historical work that's been done in building advanced reading interfaces that can provide us some inspiration that suggests that we can actually provide interactions that help people with reading. So let me share a few of my favorite example projects. Up on the screen here, you can see a tablet app that's called Inquire Biology. And this is an interactive biology textbook for the tablet that was meant for school-level biology instruction. And some of the features within this tool was essentially they would automatically process the entire biology text, extract out a bunch of entities and relationships, and then they could make definitions of individual terms available on click, such as for a concentration gradient that you can see there. They also supported in situ question answering. So they would, from these lists of entities and relationships, they would populate these lists of questions that people could ask. And then in the margins of the text, you can write these questions and see the answers right there. Another version that I think most of us have encountered in one form or another is Wikipedia page previews. So one of the issues with Wikipedia, with having all of this interlinked information, is that in order to truly understand a subject, oftentimes you need to click through multiple different links. And one way that Wikipedia has sought to try to facilitate kind of this multi-document reading a little bit better is a while ago they introduced these page previews where you can highlight, where you can hover over a link, and it will show you a little blurb from the page that it's linked to, including a brief text description and perhaps an image. And this might be just enough for someone to understand enough so that they can continue reading without having to delve into that page. One of my favorite examples comes from source code reading. So one of the lines of research that we're doing in my group relates to source code comprehension and understanding some of the most complex programs. And there have been years and years of work that have gone into helping people understand complex programs. And so if you take something like the VS Code source editor, some of the features that you might see is, for instance, the ability to hover over individual functions or variables, and you can see any documentation that's associated with that variable or function. There's also some of these cool features around doing some analysis of the code to understand which parts of it are dead or irrelevant. And so what you can see is that in this particular file, the variables absolute tech path and tech name are low-lighted, which means that they're not actually used anywhere else in the program. And so this is one way that you can help attract someone's attention to certain places that are necessary and kind of direct it away from the places where it's not. Here's a project called Book Buddy that's actually from a Stanford research group. And this is meant for young children. And what it does is it embeds this conversational agent directly within the book reading experience and allows interactions around, for instance, quizzes that can be seen right alongside the text. Here's one more example that I particularly love. So there was this project called the Voyager Interactive Book Series back in the mid-90s. And they experimented with a lot of these different ways of being able to bring interactivity into the documents that we read, including in this particular book by Don Norman, Things That Make Us Smart, Don Norman himself, who will come in and give his own editorializing on some of the content within the book. So if you were to click on Don Norman, here's the additional explanation that he would provide.
That little tiny rectangle, the close box, you have to get the cursor exactly over it and click it in order to get rid of me.
Can we turn up the volume?
Hard to reach, hard to hit.
I think I did turn it down. If I have control over this. Let's try this one more time.
That little tiny rectangle, the close box, you have to get the cursor exactly over it.
It's a little bit flaky, but essentially what Don Norman is doing is he's talking about
hard to reach, hard to hit.
The difficulty of understanding what that little close box in the edge of a window is going to be able to provide the functionality of dismissing that window. So this is one particular instantiation of interactive text where you provide these explanations that are provided by real people directly within the text. I think it's a timely question to ask. What are the different ways in which we can imbue some of these affordances, bring some of these affordances into scientific papers? Because there's a large number of initiatives to try to bring interactivity to papers. So for instance, the Semantic Scholar team, which I work very closely with, is very interested in being able to build out interactive papers to supplement their scholarly search engine. And you can also see on portals like eLifelens, ScienceDirect, ResearchGate, and a number of different services that we encounter every day that they're experimenting with interaction in many different ways, which ultimately raises this question of what an interactive paper should do. And the spoilers for this talk is that I'm going to try to convince all of you of a set of functionality that I think interactive papers should have, why I think that's the case, and what it would take to actually build interactive papers that provided this functionality. And so what I would pose is that perhaps an interactive paper should first at least define terms. So when someone selects a term that they don't understand, for instance, the name of this method in this table of results in this machine learning paper, it should provide a definition of that term in context. I also think that it should help explain notation. So for instance, perhaps it should make definitions of expressions within mathematical formulas available to people, and perhaps at multiple levels of resolution too, where you could click to drill down into individual sub-expressions to understand those as well. I think an interactive paper should enliven the static. So rather than having a derivation that appears like this one that you can see on the left, that essentially kind of extrudes this formula into multiple snapshots over time, maybe instead you can convey the same information by, for instance, highlighting certain expressions of interest and visually showing how one of those formulas transforms into another through, for instance, use of animation. And I think an interactive paper should also simplify the complex. So given a very complex passage like this one from a biomedical paper, perhaps it should be possible for someone to access a simplification of that text that will allow them to access, to understand the basic contents of that text at a glance before they invest the time of reading that whole passage in greater detail. So that's the basic set of affordances that I'll be talking about today. And while talking about these, I'll be talking about how, in order to arrive at these interactions and try to develop them in a satisfying way, we both need an understanding of readers' precise interactions with scientific articles. We also need to apply text analyses of various kinds to different representations of the scientific articles. And then we need to design powerful, tightly integrated interactive features within those articles. And the methodology that I use for this research is one that I think should be very familiar to many of you, which is a technical HCI approach. We begin much of this work with formative studies, and then we iteratively construct systems, bringing together both interactive prototyping as well as different types of text analyses, and ultimately evaluate these systems in both lab and other types of settings as well. So now that you have a sense of the vision of this work, you can consider the rest of this talk as divided into essentially 4 chapters. The first 3, where we talk about these 3 different types of main affordances that an interactive paper should perhaps have, and then talking about an agenda for what it would take to really kind of bring this interactive papers vision to fruition. And one of the things that I'll note is that for these first 2 talks, I'm a person who thinks a lot about formalisms and notations. We will spend a lot of time talking about notation and symbols. And then that last the chapter on simplifying the complex will bring it back to text comprehension more broadly. So let's talk about what it would take to make interactive papers that could define terms and symbols. We can take this back to the initial motivation that I shared with you, that essentially within an individual paper, if you want to understand the contents of that paper, oftentimes you need to orient yourself with many acronyms, symbols, and invented terms that have been introduced within that paper. And one might think that a solution to this problem would be relatively simple. For instance, couldn't you just take a given symbol or a given term within a paper, and then you just show the definition of it right adjacent to that term or symbol? We'll talk a little bit more about what it would actually take to bring this to reality, some of the nuance in the design in a second. There's reason to believe that in a short amount of time, we will have definition detection technology that will be able to find all of these definitions of terms and symbols within papers. For instance, there's a number of different types of techniques around automatic definition detection that can, for instance, take in a sentence like TL is transfer learning and derive from it both the terms that are mentioned within this sentence, as well as the definitions that are produced. And these techniques are producing better results year by year. For instance, in 2020, one of my colleagues, Dong-Yup Kang, produced a state-of-the-art model that was achieving 70% F1, which is pretty good. It's starting to get into the realm of reality, still has a ways to go. But again, now that we're in 2023, as we see more and more advances with large language models, this is bringing this increasingly closer to reality. So assuming that we have these backends, then this brings us to this design problem of, let's say, given a symbol like this letter H, and given a definition like attention head, and also given the fact that it appears in this passage that has many other instances of that letter H and many other symbols and terms, this raises the question of how should a reader request information about a symbol like this, or what information about H should they be shown? And so the exercise that I want to pose to all of you is, when you spend 30 seconds thinking yourself about what it would look like to effectively request information for this symbol, and then what it would look like to present information effectively to someone following that request. So now that you've had some time to think up your own solution to this problem, I want to talk through some of the nuance that you might have noticed in trying to surface this definitional information. So a first challenge is simply that these terms and symbols appear within dense passages. And so any information that you surface is necessarily going to occlude other text within that passage that someone might still be referencing in order to understand that sentence that they're reading. And so you want to minimize that occlusion. A second challenge is that symbols, terms as well, but symbols especially, are often understood in context. Someone's task might not necessarily be to understand an individual symbol, but rather to understand the larger structures in which they appear, for instance, within formulas. A third challenge is that symbols in particular are compositional. And so it's not necessarily enough to expose information about high-level symbols, but you might want to allow people to drill down to multiple different levels. So I want to pose another question to you, which is, how many symbols are in the equation that you see on the screen? 6. OK, got a 6. Does someone else want to venture? You heard a 7?
It's one J.
Is equals a symbol? Are parentheses a symbol? So it becomes a bit ambiguous, and it also is a bit reader dependent too. But one of the things that I would wager is that there are at least 12 symbols within this formula. Or if you look at the lowest level of this formula, like if you were to turn it into a parse tree and just look at the leaf nodes, you would have M, H, and J on the left-hand side as your kind of lowest level symbols that someone might want to understand. And at the next level up, you have another 3, which are these kind of higher level terms. And then you might also have the equals and in parentheses too. But I would say that it's at least 12, and you would want someone to be able to access helpful information about each of these. And a fourth challenge is that symbols often have multiple meanings too. So for instance, here I pulled 2 examples from one specific paper in which T was used in 3 different senses. Here you can see 2 of them. In one case, T is used in the matrix transposition operator, and in another one, it means the number of token representations. And so from this, you might start to see how simply saying throw a tooltip at it is not necessarily kind of a sufficient solution. You need some attention to some of this nuance. And for us, we ended up distilling this down into a set of 7 requirements around providing these position-sensitive definitions of terms and symbols within papers. And this was on the basis of 5 formative studies that we conducted, including interviews, observations, focus groups, and so on and so forth, with different iterations of our interactive reader at different times. And altogether, we ended up bringing all of this together and reifying it in a tool that we called Scholarify. And Scholarify tries to encode some of this nuance about how you surface some of this definition information within an interactive paper. And let me walk you through what it would look like to interact with a paper with Scholarify. So the first feature with Scholarify is simply supporting this multiple level kind of drill down to access definitions of individual symbols. So if you wanted to get to that H right by the cursor, the way that you would get to it is you would first click on the parent symbol. And then once that's clicked, you can see that a number of sub-targets become available within that symbol, which you can then click. And if you have kind of a mega symbol that has multiple levels of subscripts, essentially what will happen is you just you click on kind of the grandparent element, and you continually drill down into the sub-elements. This ends up supporting an efficient way of accessing those definitions in a way that all of those definitions are somehow available. And then as someone clicks on those symbols and terms, what you'll see is this compact definition tooltip, which has been designed for economy so that it does not include the surrounding text. And it has a few of these main components to it. Of course, first it has the definition. That's kind of the key component you can't leave out. Then it has this hyperlink to the definition in context, because oftentimes we understand these terms and symbols by the company that they keep, and we want to jump to those passages to learn more about them. And then there are also these buttons that open up lists of definitions, formulas, and usages. And those little buttons, too, even provide scent unto themselves by, if they're disabled, that suggests there's only one sense of that term or symbol. If they're enabled, then you can even hover over them to get a sense of how many terms and symbols. And it'll open up those lists in a sidebar. And so when someone clicks on that link to the definition in context, again, we're trying to go to the work of reducing extraneous load, trying to do as much work on the behalf of a reader as possible. We highlight the passage that the definition came from, that individual sentence in blue, to be able to attract someone's attention to it right away. You'll also see this feature of when someone clicks on an individual formula that they want to understand. We try to support bringing together multiple of these definitions that might need to understand it at once. So someone can click on that equation diagram, and what they'll see is the definitions for all of the symbols at each of the different levels of hierarchy at which they're available. And they're arrayed on the outside of this formula using a simple automatic label layout algorithm so that someone can rapidly check up on the definitions of individual symbols all side by side. And because once again, the meaning of a term or a symbol can often be determined based on the company that it keeps, someone might be interested in seeing all of these usages in context really quickly. And so we introduced this feature that we call declutter, which means that when someone clicks on a term like this D&M that you can see right here, what happens is that all passages that contain it are automatically highlighted. All of the remaining ones are low-lighted and visually de-emphasized. And what this allows someone to do is to once again find out all of the information in context within the paper for this term by simply just scrolling through the paper and looking at those emphasized passages. So altogether, those interactions, the main philosophy behind all of them is trying to consolidate this explanatory information about the terms and symbols while also trying to reduce occlusion. In order to get a sense of how an interaction like this could support the reading experience, we conducted an in-lab usability study. We had 27 researchers come and we had them undertake both timed tasks as well as unstructured ones. In the timed tasks, we asked them questions that required an understanding of the terms and symbols. And in the open-ended task, we asked them to read the paper for 20 minutes of unstructured reading time using the features however they chose. And what we ended up seeing is that For the timed tasks, when participants were asked to answer questions that required an understanding of the terms and symbols, they were capable of doing so in significantly less time, and they also viewed less of the paper and traversed significantly less of the paper. And at the same time, they also reported significantly higher ease and confidence in doing so. A type of effect that you would hope for if you're trying to reduce extraneous load as people are trying to answer some of these understand these fine-grained aspects of the text. And then when we observed people using these features, we started to see a couple of trends. So out of the features that we produced, the definition tooltips and the equation diagrams were seen as kind of the home run, knock it out of the park. Essentially, all participants said that they would use them often or always if they were present. And I believe almost all, if not all, participants used them during the unstructured reading task. The declutter feature was also used and seen as useful, but to a lesser extent. The definition tooltips and equation diagrams were really kind of those main features. We also started to see some of these emergent behaviors that we would expect to arise in more naturalistic reading settings once someone has some of these kind of primitive tools at their disposal. So some of my own favorites were one participant who was using these tooltips not just to fill themselves in on the meaning of a term to begin with, but to check their understanding, to kind of administer a self-mini quiz right in the middle of reading. Another example was a reader who read a technical section by jumping from one equation to the other and just looking at the equation diagrams and skipping the interleaving texts. And these are essentially kind of resemblant of what we think are a bunch of things that people would try to do to scaffold their reading in different ways once these primitives became available. Now, this was our first project in the augmented reading space, but at the same time, it was enough for us. I was collaborating with the Semantic Scholar team. They make a free online literature search engine, and we were all excited enough by these results that they started on this product initiative called the Semantic Reader to try to bring some of this interactive reading to the Semantic Scholar site. These days, it has some features around helping people understand citations, and they're also experimenting with more and more. If you follow its Twitter feed, you can be part of some of the pilot studies for some of those tools. So all of that to say, this was something that ended up leading to some of these longer initiatives that you'll continue to see some of the work that has arisen out of. Now, the research effort around this work is not just to understand kind of the top half of this slide that you can see here around what the user interfaces should look like around interactive papers, but to also understand some of the nuance around the things that we might have overlooked that we might need from analyzing these papers to make these interactions possible. We've already talked a little bit about definition detection, where that is and where it's going. Another thing that I want to highlight as something that is kind of hidden in plain sight is the efforts around symbol localization, which actually ends up being a relatively tricky problem. How do you find symbols and their precise bounding boxes within a paper unambiguously? And so where we started for this is simply to make the initial assumption that we have the LaTeX available for the paper. This is an assumption you can make for like the 1.5 million papers on arXiv. It's one that you can't make for the remaining like 100 million or so research articles that are out there. Hopefully with LaTeX, you could train a machine learning algorithm that would work for the rest of this stuff, but we at least have to start somewhere. And so what we did with LaTeX was we essentially did this kind of big old hack in order to try to figure out those precise symbol locations. And let me walk you through what that ends up looking like. So let's say you have the LaTeX for a passage that contains a formula in it, like this one that you can see right here. If you were to render that LaTeX into a PDF and then raster that as a bitmap, you would end up getting this pixelized version that you can see on the right. And one of the ways that you could detect the pixel locations of that formula is if you then wrapped that formula in some coloring command, for instance, to color it orange, you re-raster it, and then you just diff those two images with each other. That leaves you just the colorized pixels for that individual formula. And then you can just use a blob detector that just does kind of a conservative box around all of it, and that's your bounding box for the formula. That will get you a precise bounding box location for that individual formula. Now, how do we drill down into the individual pieces of that formula to the symbols at each of the different levels? Recall that, again, the problem is that the equation that you can see right here, it doesn't contain 5 symbols or 2 symbols. It actually contains 8 symbols in it, at least 8 symbols in it. And so one thing that we can do in this case is we can try to derive some of the structure that we might want to detect within this formula. So we can take the LaTeX that we've already detected within the document, and then we could pass it through some type of parser. For instance, Katek has like an off-the-shelf open source parser for LaTeX. And then you end up getting the symbol tree. And each of those leaf nodes are the individual characters within that formula. And then what you can do is, as long as you have the character offsets of each of those leaf nodes, you can go in and you can colorize each of those different symbols, each of those different tokens. You can even batch colorize them different colors of the rainbow and detect them all at once using different hues or something like that. And then once you identify those individual tokens, you can use that structural information to coalesce it into these higher level bounding boxes. And so this is the type of analysis that we need in order to be able to provide these kind of more satisfying interactions that allow drill down into those individual definitions. This particular technique is better than anything that we were able to achieve with machine learning at the time. We're getting a precision of 96%, a recall of 88%. Those of you who are really interested in why a rule-based approach didn't get 100% on both, I'd be happy to talk about some of the minutiae of tech that ends up arising when you try to do something like this. It's really interesting, but also really esoteric. But ends up getting a high enough precision that it starts to feel actually rather good within a paper. So I talked about how the first part of this talk would talk about notation. And I want to do a little bit of a further dive into talking about symbols and formulas and trying to uncover the horizon of the types of things that we could do with symbols and formulas to be able to support people's understanding of them. And this brings us to our second chapter on explaining notation in particular. So let's say you are a person who didn't understand the equation for a line right here. There's a couple of ways that we might be able to explain this formula. One of these approaches is the approach that I described just before, which is you could add descriptive labels to that formula. For instance, conveying that this formula means that you can compute the height of a point on a line by taking a horizontal position of that point, multiplying it by a multiplicative factor called the slope, and then adding it to some constant offset. I think this is how a lot of us would look at this formula. There's at least one other approach that you could take to this, which is a more pictorial approach, which is what if you could show what this formula means pictorially? And you could show a visualization kind of like this. And then you could colorize the formula in order to try to visually link the two together in a way that conveys that the height of this point on this line, you can get there by taking this constant vertical offset and then taking the horizontal offset of this point on the line, multiplying it by this factor, adding it all together, and then you end up with this, computing this height. Which ends up raising this question, are there other mechanisms that we can use in order to help explain notation? What might those mechanisms be, and what might be the barriers in place to us being able to integrate those into our current reading experiences? So for this project, our goal was to understand how future scholarly authoring tools and document processing tools could support more rich explanations of math notation. And this was a project that was entirely mixed methods and qualitative. We undertook two different studies. One of them was a content analysis, where we took a look at 47 math documents with what we called augmented math notation, essentially math notation with visual embellishments to try to support readability. And then we analyzed about 300 formulas that came from those documents. And then we undertook a series of interviews with 12 authors of these documents to try to understand the processes by which they arrived at a particular representation, and then the efforts that they had to go through to bring this representation into their documents. The content analysis ended up being quite effortful. It involved 2 coders. Each of us inspected 281 formulas by classifying and counting augmentations. And this involved around 8,000 judgments apiece across all of these different formulas. And because it was such detail-oriented work, it ended up being about 50 hours each or so through those kind of multiple iterations. And this ended up leading us to this taxonomy of different ways in which notation can be augmented, which we boiled down to 4 different categories. One of these categories is what we call visual notation, which is taking visualizations and embedding them directly as expressions within the formula. For instance, geometric objects or little graphs upon which represented data upon which computation was being performed. There's text styling. So for instance, introducing color and spacing into a text, doing these different types of text formatting to convey meaning. There's annotations, for instance, introducing labels or borders or other types of marks on top of the formula. And then there was also interactivity. So a number of these formulas enabled people to, for instance, click and drag on expressions within those formulas in order to modulate their values. Some of them even had ways of trickling down those computations to kind of downstream values that appeared on the left-hand side of that formula, and so on and so forth. So those are the 4 overall categories. And when you look at them in fine-grained detail, are actually 16 different kinds of augmentation that we observed across these different types of documents, which just shows that there's actually this relatively large space of types of expressions of augmentations that one would want to support if they wanted to be able to support the types of things that we were already seeing in the wild. Taking this taxonomy together with our interviews with these authors, this ended up leading us to a number of recommendations about if we were to try to support the kinds of practices that they were talking about, what would you make possible in contemporary authoring tools? So the first recommendation is to help authors color formulas and the content that those formulas relate to. We saw in the vast majority of the documents that they made use of color to highlight important expressions and then relate them to explanations and representations elsewhere in the document. So here you can see an example from one such document. And the use of the color green in this particular formula is just meant to provide an easy way of scanning back and forth between that f of x and the curve that it corresponds to in the nearby visualization. This pattern was really common, and it was used to link formulas not only to visualizations, but also text and code listings. We also saw some desire among these authors to better support details on demand and animations. So details on demand would be kind of the sort that we described with equation diagrams before. The animations, one of the visions that we saw of this was the one that I shared before, which is that there's this one author who had this derivation that took place over the course of, I think, 8 steps. You can see 2 of those steps right here. And there's a lot of this kind of accompanying text that describes how to perform these primitive manipulations to that formula in order to transform it into the other one. And actually, straight out of this particular participant's mouth, they said, well, I might just want to highlight that gamma and then just show where it goes within the next formula. Of course, animation isn't necessarily the only way that you can convey this information, but it at least indicates the fact that a lot of the time text is carrying the weight of something that can be shown perhaps more effectively in some other type of visual representation. Another recommendation is, I think, after we use the tools for long enough, sometimes it's easy to forget that the markup languages that we use are sometimes clunky to read and write. And so, for instance, for a relatively simple formula like the one that you can see here that just has 8 colorized symbols within it, the code in order to produce it is what you can see right here. It ends up becoming, I think it's like a 400-character long listing. And what's particularly clunky about this particular example is the way that it mixes together the formula specification, which is now fragmented and way spread out, with the augmentation specification, which is kind of surrounding it and splitting it up in all of these different places. And so one might think that you might be able to fix this fragmentation problem and also some of the verbosity problem with another type of design. So for instance, if you were to come up with like a CSS for formulas, maybe instead it would look like you would have your content markup for the formula, what would just be the formula, and allow people to continue to look at that text for the formula as usual. And then you would have your presentation markup, which allows people to, for instance, select different types of expressions and then apply simple styles to them with a more concise, readable syntax. So those 3 design recommendations I shared with you are just 3 of 11 that we came up with in this paper on the basis of the observations of both the documents and the interviews. If you're really interested in this, I think that there's a whole lot of really cool tools that can be built in this space in order to help people interact with formulas more effectively. So I encourage you to take a look at the paper if this is piquing your curiosity. But if I were to take a step back, I would say that the overall takeaways from that particular study was that to support rich explanations of math notation, our scholarly media and authoring tools should be extended to support linking of text and notation, supporting a wide variety of annotations, and also perhaps in judicious, in appropriate circumstances, supporting more dynamic formula presentations. So let's go back to this more general problem of helping people understand texts through interactivity. We started out this talk talking about the prevalence of vocabulary and trying to help people understand individual terms and symbols. But I think that there is a particular critique that can be leveled against this, which is that sometimes the problems with understanding the text cannot be explained purely by vocabulary. And so here's a quote from Mark Halliday, who's a renowned linguist. And he wrote this paper on grammatical problems in understanding scientific English. And I really like what he writes here in that he wrote, In order to understand why scientific writing has become difficult in certain ways, we shall need to get rid of our obsession with words. The difficulty lies more with the grammar than with the vocabulary. And I think that we can see some of what Mark Halliday was saying if we look at a passage from, for instance, a biomedical text. And I'm just going to read this passage out loud, where you start to see that the problem isn't necessarily individual words, but perhaps the ways that they're being combined together. And this passage reads, "The most salient events include an impaired apoptosis of dying cells, a type 1 interferon signature, the uncontrolled activation of T and B lymphocytes, and the production of autoantibodies, mainly directed against nucleic acids or ribonucleoproteins." So here's a case where the terminology is so dense, and also the structure of the sentence is complex enough that it's going to be difficult for someone to understand this, even if they understand each of the individual terms. This ended up leading to our third chapter, which is on simplifying the complex in interactive papers. The particular focus of this project was to try to kind of take this to the extreme of trying to kind of democratize access to a paper. We were really interested in thinking about if you took healthcare consumers and tried to allow them to access some of the latest results about conditions and treatments in the medical literature, as oftentimes they desire to do, how would you be able to do that with an interface? And the lead for this project is Tal August. If you're interested in his work, you should definitely check it out. He does some great work in HCI and NLP. He's on the job market right now, and I think really excited to talk about a lot of these different types of projects that he worked on. So this project, like many of our others, began with some formative research. In this case, we conducted interviews with healthcare consumers and then observation studies with non-expert readers around biomedical papers. And through these observations and interviews, we ended up distilling this set of questions that people would ask while reading these biomedical papers without domain expertise. Some of these questions might be things like, what should I read? Another question might be, where can I find an answer to a specific question that I have about a text? And then, rather than asking a question about what this term means, they might have the question of, what does this passage as a whole mean? These were 3 of the 5 questions that we ended up illuminating, and I want to talk about them in particular. We ended up developing this interface called Paper Plain. Plain in the title meaning referring to the plain language summaries that we intended to incorporate into the reading experience in order to help people understand the complex information within that paper. And it was designed to answer these 3 questions. So within Paper Plain, the first aspect that you'll notice that's different from a conventional PDF reader is that instead of your typical navigation for a paper, you instead have this bar on the left, which is called the Key Question Index. And what this Key Question Index does is it lists these 8 common questions that lay audiences might wish to ask about biomedical research. And so implicitly, this Key Question Index is intended to answer this question of what should I read? Essentially, it queues up these different sets of things that someone might be interested about within this particular paper. And then when a reader has a particular one of these questions that they want to understand better, they can move their mouse over to it, and they can highlight it. And then just the act of hovering over that particular question ends up answering this second question of, where can I find an answer to my question? Because when someone hovers over that text, it will highlight the corresponding passage within the text. And then when someone clicks on that particular question, it will then jump them to that answering passage. And then this brings us to the answer to the third question, in particular of, what does this passage mean? And so what you can see is that whenever someone jumps to an answer, we show what is called an answer gist, which is a plain language summary of the content, the answering passage. And so I'll just briefly read this gist for you up on the screen to give you a better sense of the type of language that this gist is written in contrast to the passage I read you before. This just reads, systemic lupus erythematosus is a disease that affects about 5 million people in the world, mostly women. It is an autoimmune disease, which means that your body attacks itself. It can affect many different parts of your body, including your kidneys and your brain. It can be unpredictable, meaning that it can change from being active to being quiet. It can flare up when you get sick or have a cold. And so the idea behind these summaries is that they're meant to state things in simpler sentences with simpler terminology that are going to be more approachable, but still being adjacent to the original text to allow someone to go back and look at that kind of ground truth. And so paper plane doesn't just provide these gists related to the answers within the paper, but essentially they allow people to ask them about any section that they'd like. So given a section like this one, which is a very long description of a particular type of, I believe, therapeutic peptide that is being covered within this paper, someone can click on that flag right next to that section, and then they end up seeing, once again, what is a briefer and more plainly stated summary of that section, which would help them be able to understand, for instance, should I even bother looking at this particular section? Does it contain the kinds of information that I might wish to understand? So in this way, paper plane was designed to answer the questions of what should I read, where can I find an answer to my question, and what does this passage mean? And as with Scholarify, one of the tasks of this research was to get a sense of what it would take to build up an interactive paper like this. And in our experience, what implementing a paper simplifier entailed was a number of different implementation choices. So for the key choices in particular, those questions were chosen from the PICO set of questions, as well as the questions that came from the Cochrane Guide on writing understandable summaries of biomedical research. And so we essentially kind of joined together, merged together, and consolidated those sets of questions into the key questions that you saw there. The answers to the key questions were extracted by applying a model that was trained on the bioask text to all of the paragraphs within the paper, and any paragraph that yielded an answer was seen as an answering question, an answering passage. And then the plain language summaries were generated by GPT-3. I think a lot of us have been playing around with GPT-3 and other related large language models these days. What we essentially did was we took text from the answering passages or from the sections, and then we passed it through a prompt asking it to re-explain it as if it was trying to describe the same passage at a 5th grade reading level. And to try to get a sense of the ways in which these types of affordances would affect the reading experience, we conducted a study with 24 non-expert readers. We had them undertake a reading task where they read a paper for 10 minutes and then answered questions about that paper. And then, and we also, we had a partial within subjects design where each reader was assigned to 2 of 4 interfaces which were essentially different ablations of the different features of paper plane. And one of our observations from this study was that we started to see this transition from not using paper plane to paper plane, where we saw people going from more exhaustive reading patterns to more piecemeal reading patterns. So let me decompose this visualization a little bit. One of these curves is one reader on one paper. And the position on the y-axis corresponds to their position within the paper. So for this particular person, you can see that up until around minute 4 or 5 or so, they were mostly in the beginning of the paper. Then they jumped towards the end. They jumped back to kind of the beginning, and then they jumped to the end again, and then kind of scrolled back up to the top. So that's how to read that particular curve. And what I want to highlight is, if you look at this particular set of curves, which corresponds to when people were using a conventional, when people did not have access to the key question index, you saw what essentially looks like this exhaustive linear reading, where people kind of just slowly plod along from the beginning to the end of the paper, sometimes jumping back for a second pass. When you look at the key question index, you start to see more of this kind of piecemeal sampling of the paper. A lot of this, I don't show it on this chart, but a lot of this ends up corresponding to a lot more time spent in the introduction and the discussion of the paper, which tend to be the kind of more approachable parts of it. And what we ended up seeing is that participants jumped to answers an average of 10 times when the key question index was available, suggesting that this was seen as something that kind of helped them navigate to that relevant content. Another thing that I'll also mention is that we also saw a statistically significantly longer fixation time when the key question index was available, which suggested that at any given place where someone stopped, they were spending more time looking at that information there, which was an interesting observation. We can't necessarily say that led to better understanding, so to speak, or better engagement, but it was a marked difference in the reading process. Now, the effect on understanding papers was a little bit confusing from the perspective of trying to reconcile different signals that we got from this study. So on the one hand, participants reported that it was less difficult to read the paper and that they better understood the paper when using paper plane, which is great, a big upgrade if people feel that a paper is more approachable with the use of these kinds of features. That said, participants answered questions about the paper about as correctly with both paper plane and the baseline. And so this about as correctly is not just kind of lack of statistical significance. We did a follow-up non-inferiority test, and they were shown as kind of statistically likely to be for neither of them to be inferior or superior to each other. So all this suggests that I think, first of all, comprehension is this really complex thing. These 10-minute interactions with a tool are perhaps not enough to move the needle on it. And we need to keep inquiring about how to build these tools to move the needle on understandable metrics, on these kind of quantifiable metrics of understandability. I guess at the same time, one of the things that is good is that some of these simplifications do not seem to diminish the ability to answer those questions, but rather it was able to at least keep parity. So I want to take a step back and to try to talk about how we can bring about a vision of more comprehensive interactive papers. So first, just taking stock of what we've talked about so far, we've talked about how an interactive paper should define terms, explain notation, enliven the static, and simplify the complex. The way that I would summarize the findings from the studies that we've run so far is that readers desire tools for looking up definitions of terms and symbols. Authoring tools are not keeping pace with kinds of explanations authors would like to provide, and that readers report lower difficulty reading papers with in situ simplifications. But one might also notice that there's a lot more than an interactive paper could do, particularly for different kinds of reading modes. For instance, maybe when someone is skimming, an interactive paper could draw attention to important passages. Or maybe when someone is conducting some early stage research within an area, an interactive paper could draw attention to important citations. And in fact, some of my collaborators, in some of my collaborations with the Semantic Scholar team, we've been exploring a lot of these ideas too. So to just describe a bit of the emerging work that you'll see at conferences just later this year, Raymond Fox just led this project on this project called SKIM, which is the word skim but with a C for science, and it provided intelligent skimming support. And so what this tool does is it processes the paper and then it highlights sentences according to 4 different facets of whether they talk about methods, objectives, novelty statements, or results. And it tries to distribute these highlights in such a way that will allow people to kind of gain purchase on kind of that messy middle of the paper that you might not get using your conventional skimming heuristics. So this is a project that we recently worked on to try to help people with this process of rapidly extracting a lot of information out of a paper during a skim. Another project that was intended to help someone get better orientation to the literature was this project called CiteSee, which was led by Joseph Chi Chong. And the parts of the CiteSee interface that I want to draw your attention to is, first of all, you have these highlighted citations. And these citations become highlighted when you see them for a second or a later time while reading papers. So CiteSee keeps track of the papers that you've seen in the past, and if these citations keep appearing time and time again, it'll start letting you know about that in order to try to convey, you might want to read this by now. And in this tooltip that you can see right here, there's this additional information that tries to convey information about those contexts in which you learned about this citation before. So for instance, this particular citation was cited by one of the recent readings, which was a crystalline paper. You had scrolled 83% of the way through the paper, and the citation context within that paper in which you had originally seen it was this one right here. So what it's trying to do is essentially take what might have been a much more difficult task of trying to understand the context in which you encountered these citations and to try to bring all of that information into one place to help you make those kind of momentary decisions about what to do with an individual citation. I think there's also an important question about how we can do all of these things in a way that best befits an individual reader rather than making these kind of all one-size-fits-all interactions. And so one might ask, how could you personalize the reading experience? Noticing that, for instance, that within a particular page of a paper, you might have these different classes of these terms that belong to these different domains, and people might be familiar with one of those domains but not another. So within this particular page, there are these terms that are related to deep learning. There are these terms that are related to computational linguistics. There are terms related to other types of domains too, and any given reader is going to have familiarity with some of those and not with others. How do we help detect certain clusters of terms that are going to be relevant to a particular person? There's also this challenge of figuring out how to explain it in a way that's approachable to a particular person. So for instance, you could describe a softmax function in a couple of ways which might befit different readers. You could describe it as simply just a function that maps from this infinite domain into a value from 0 to 1. And that might just be sufficient for some people to know. Other people might be interested in the kind of formally specified definition of it. And so perhaps we should understand the types of things that readers know and personalize these definitions to them using the language of the user. And across all of these different projects, what we need to do is essentially orchestrate a whole lot of different techniques, from document analysis, where it can detect entities in bounding boxes, to work with publishers in order to make documents interactive and to distribute authoring tools, to work with NLP researchers for technologies to simplify texts, reduce hallucinations in those texts and beyond, and also us HCI researchers, of course, trying to take the lead in understanding these different reading modes and the different forms of support that we can provide in really kind of nuanced detail as they might manifest in these really complex information artifacts. In order to help us fit what can be oftentimes these very complex papers into our minds and then be able to benefit from the collective knowledge that we've all been cultivating as a research community. And with that, I'd like to welcome questions.
I don't know if this is on. Thank you for a great talk, Andrew. My question was, I wanted to get your thoughts on sort of like, I feel like you presented a lot of work on augmenting like existing text, but I think there's been some conversation around, for instance, like having videos being embedded in papers, or like why are PDFs like 8.5 by 11 if they're being consumed online? Like that seems like an arbitrary restriction. So I guess like, what are your takes or thoughts on different kinds of interactivity in papers beyond sort of like, like augmenting the text that's there?
Yeah, I think that's a great point. So I think there's a bit of a philosophy behind a lot of the work that you saw today around essentially trying to improve a text by incorporating additional reference information in a timely way. And I think that there's a lot of really exciting things to be pursued. And for instance, aligning text to like slide lectures and video talks and that kind of stuff. And I also think that what you also identified, that like giving additional breathability and reflowing the text is another way that you can do this as well. I think all of that work needs to be done and should be done. Some of my colleagues at Semantic Scholar have worked on some of that stuff too. For instance, one of the projects that they worked on was called SciAlly, and what it does is it takes a PDF version of a paper and then generates a reflowable text version of it with some additional accessibility features in it as well. So I think that work should be done, and so we should work on that as well.
So yeah, it was great to see all the examples, Andrew. I have a question about what happens when the automated summaries or the other automated things are incorrect, right? There's a big potential for leading someone astray. And how do you think about that, and what should be done there?
Yeah, that's a great question. And in fact, one thing that I skipped over in the interest of getting to the end of this talk, but I did want to talk about is this whole challenge of hallucinations in some of this generated text. So the fact that we picked biomedicine as a challenge area, it really highlights the potential downsides of hallucinations, in that a patient might end up drawing incorrect conclusions about potential conditions and treatments, has real impact on their health and well-being. And so to validate your concern, one example that I do have here is a place where, an example simplification that we did where here's an excerpt that you can see and its corresponding generated gist. And so on the left-hand side, you can see that kind of the concluding statement is the median JADA score of the cohort studies was 6, indicating that these studies were of high quality. And on the right-hand side, you can see that kind of the concluding statement is the study found that all 3 types of surgery were effective for treating the problem. And so this is an example where essentially there was kind of this hallucination of this conclusion that was never explicitly stated within that text. And so we thought about this a lot as part of this project, and I think it's something that we as a community need to kind of continue referring to, like how we accept the fact that hallucinations are a part of lots of these models and responsibly deploy them. The ways that we thought about it for this particular project is that First, the simplification should appear adjacent to the source text. So one of the ways that we were thinking about this project is that we don't just want to kind of staple a summary to the very beginning of the text, but rather we want to have these simplifications be kind of like an index into the text. It's a reason why we don't occlude the text with any of those descriptions either, because our hope is that someone is going to eventually bottom out at that original text to get to that kind of authoritative description. Second, generated text should be clearly marked as such, so it should be clear to people this was generated. And then third, I think in the long term, incorporating some technologies around checking facts and hallucinations and that kind of stuff is something that should be done to make sure to reduce to the extent possible the prevalence of those hallucinations. So those are some of the ways that we've thought about it so far, but I think it's a really important point that needs to be considered with the creation of all of these technologies.
Yeah, I think relying on the user to check doesn't simplify reading, right? Or doesn't make it easier, right? It makes it potentially harder. So that could be at odds with what you're trying to do.
Yeah, I think that's a good point. I mean, I think one of the ways that I think about the paper plane project, I think about the simplifications as vehicles into the text rather than replacements for it. I think that, of course, there's a temptation as soon as you introduce a simplification that someone is going to read purely that and not the original text too. And so I think that is a risk and perhaps one that we haven't solved. But I think that, philosophically, I don't necessarily think about completely removing the need to read that original text as that wasn't my goal in this project. And I think that perhaps it shouldn't be our goal, at least for domains like biomedical texts.
Hello. Yeah, I have a question. Cool. I really liked the talk, particularly when you were motivating within the relative work, and you talked about the textbooks where it was created an interactive avenue for students to be able to see and understand the things that were going on within the textbook. I'm curious to have your take on when it comes to, I know this was particularly for maybe adults or something trying to read and learn about these new different types of treatments and such, but in terms of what are the possibilities, like when it comes to being able to ask a question, we're not just using the generated question, but what if I want to know, given my conditions of X, Y, Z, is this a very good and proposed method to treat my ABC? And what are the, I guess, capabilities of being able to do that just as they would with the textbook of someone could ask a question and get the answer? Would you also be able to do that within the scientific papers?
Yeah, so there are a couple of projects that have tried to address just that. So for instance, there was this project called Talk to Papers, which tried to incorporate question answering into a paper setting in order to be able to provide answers to arbitrary questions that people ask. I think it's a really good idea, and I think that if incorporated in the right way, I think it could answer a lot of questions that people have. There's also something else that that you mentioned in your question that I think is also a really interesting area for exploration, which is helping people relate the findings in a paper to their personal circumstances, especially kind of in the biomedical space, trying to understand how the results of a study might relate to them specifically, given the fact that different types of treatments and conditions affect people differently. That, in fact, was something that we found out learned about in our own formative studies as well, and something I think would be really interesting to figure out different ways of incorporating maybe question answering. I think another thing that could be looked into is other types of like patient anecdotes and that kind of stuff to help people get these very kind of people-centric descriptions of what can sometimes be very abstract results. So I think you hit upon a couple of really exciting areas for future exploration.
Hello. I have a question about, I guess maybe it's a second order effect of some of the things that you talked about. So in a world where like this is just like fully implemented into like all PDF readers, have you thought about how this changes how people write? So I can think of two ways, and one where it's just like people just write super archaic because they're like, there's going to be some model that can just understand what I'm saying. And then in another way, it's like, I'm thinking, okay, people aren't reading, like these models aren't picking up most of what I'm writing. So I'm just going to like write less text in general. Have you thought about like kind of like these effects of like these models on how people are actually going to write?
Right. So the thing that we would want to avoid, as you mentioned, is if these tools end up becoming a crutch for people's writing, where essentially they kind of offload some of the effective writing strategies to something that can be caught by an interface later on. I don't know if that would be likely to happen. I think it is something that you would want to avoid. And I think that in part, one of the things that we should maybe consider is like simultaneously making improvements to the authoring process while we're also making changes to the reading process that continue to encourage people to write in ways that are going to be approachable to other people. And in a way that kind of continues to explain that like the onus really is on the author to make their text understandable. So I don't know the effect. I think it would be a fascinating study to run, and hopefully we would not end up in such a situation.
I think we're about out of time, so let's thank Andrew for